Hello and welcome to this video looking at how to draw energy level diagrams suitable for GCSE, maybe as a refresher for A-level. It's going to be a very simple video where we just look at what we're trying to show with an energy level diagram and the two actual types. So in my previous video we looked at defining an endothermic and an exothermic reaction and how we might measure those experimentally and determine whether or not a reaction is exothermic and endothermic. An energy level diagram is very simply a way in which we can display this. So energy level diagrams are shown on an axis where we have energy on the Y and reaction progress on X. This reaction progress is simply is otherwise often called reaction coordinate. All it really is a measure of how complete the reaction is. So if we just imagine the simple reaction A plus B to C, over here we've really just got A and B. It's just our reactants, and over here we're forming our products, and it's a scale as we go across of completion of reaction. Obviously, energy, the higher up we go, the higher energy we're looking at. So if I think about an exothermic reaction, exothermic heat is exiting the chemical system, it's leaving the energy. So if we start with our reactant level up here, so I'll write reactant, because I'm on this side of reaction progress, I'm looking at my reactants. Now, if I considered an exothermic energy level diagram, and this one here, by the way, is exothermic, energy is leaving the system. That means my products are going to be at a lower energy. So I can draw them down here. Products, because on this y-axis the products are lower in energy, the rest of the energy has been lost to the system. I now need a reaction pathway, and that's going to come down like this. I've got two labels on my energy level diagram. The first one is delta H, and delta H is the energy change of the reaction. Okay, so I can label that delta H, that's energy change, and that's showing a negative energy change. Okay, delta H is negative in an exothermic reaction. The other arrow that we need to label in an exam is this one here, that's EA. Now EA is the activation energy, and that's starting at the reactant level because that's what I'm starting with. I need to do some bond breaking to overcome this pathway. If you like, I need to put energy in to get over the hill before it's released in some new bond making, which is an exothermic process, down the other side. And we'll look at how bond making is exothermic and bond breaking is endothermic when I do bond enthalpy calculations in another video. So that is my exothermic energy level diagram. Delta H coming down here, activation energy up here. And this explains why exothermic reactions are more common, because it's favourable for a system to end up at lower energy. And if it has the activation energy, it's very likely that it'll end up down at the products. The other type of reaction that we discussed last time is endothermic. So once again, I draw my axes with energy on Y, reaction progress on X. You might want to pause the video if you're feeling confident about that one and just have a little go at what this one might look like. But I'm going to go ahead and draw that now. So this time my reactant level is at a lower point because I'm taking in energy. And therefore my product level is going to be above that. I'm taking in energy, the system's going up in energy, endothermic. I then need to join these levels with a pathway, like that. And if I just, these dotted lines I'm just extending out from the reactant and product levels just so I can see exactly where I'm drawing my arrows, nice and precise. Delta H, as always, is the difference between the levels, but I need to start at the reactant level and go to the product level because I'm going to the products in the reaction. So delta H needs to come up here like this. That's my delta H, the label I need. And activation energy, obviously that's the energy needed for the reaction to happen, to overcome this, but we're starting at my reactant level. So my activation energy for an endothermic reaction, let's just get that in a better line. My activation energy goes all the way up there, EA, right from the reactant, right to the top of the energy level diagram. So for GCSE you need to be able to reproduce these, endo and exothermic. You need to be able to label delta H in both cases and activation energy in both cases. And you need to have an idea linking to the definitions of exo and endothermic reaction, what these are showing. That here we've got a negative delta H showing us it's exothermic, showing energy going out, that negative energy change. Here we've got a positive delta H, the energy is coming in. Okay, so that's all there is to talk about with energy level diagrams. There'll be a bit more in-depth explanation with this when we look at bond energy calculations. That's in the next video. As always, like, comment, subscribe, share it around, and we'll see you in the next one. Thanks very much.